Hello, Calc 3. I'm going to work two problems that were requested. I think the second problem is probably going to be a common question, so I'm going to go ahead and post this and send it to everybody. First thing here, they're wanting us to find f of x, f of y. This is just using trig. I know, given that angle, that I can do cosine of 45 degrees, and that's going to be equal to, remember, cosine is the adjacent over hypotenuse, so it's going to be fx, that part, over 30. So that means fx, if I just multiply both sides by 30, I get fx to be 30 cosine of 45 degrees. And you can use your calculator if you need to for that trig. This actually gets me 15 radical 2. That's because 30 times, and then cosine of 45 is radical 2 over 2. And then the 30 and 2 make 15. Okay, f of y. If you notice here, well, let's set it up the same way, actually. We can use sine now to get that one, sine of 45 degrees. And that's going to equal, remember, sine is opposite over hypotenuse, so it's fy over 30, which means that fy is 30 sine 45 degrees. And that's the same value, right? Sine of 45 is radical 2 over 2. It's that middle triangle, and I get 15 rad 2. So that's for that problem, where they just wanted each component. So my vector, actually, the vector in question, f, can be rewritten as 15 rad 2, comma 15 rad 2. All right, so that's number 61 from homework 3.1. I probably should have mentioned that. Not 3.1, but I think 13.1. Let me verify that. I've just switched books recently, so I'm still trying to learn these section numbers. So 13.1. Okay, and then we're going to do problem 15. This is common questions always asked. So if I take, I want to find the force 1, force 2 vectors. To kind of get an angle, what we're going to do is use some high school geometry. I didn't mean to draw a line like that. I'm going to take two parallel lines. Notice that if I draw a flat line, and I'll fix it here. Let me get it flat. And if I draw it through this dot, notice that this line that I've highlighted and this line here are both parallel. So when this happens, if I have a line running through it, like this line here, from high school geometry, if you remember, if this is 60, then this is also 60. So I know this angle is 60 degrees. And then I can use that same logic here, right, across from there, and I know this one's 60 degrees. Right? I also know, this is a static question where all forces, let's name this F going down, so F1, or F3, sorry, F1 plus F2 plus F3, all three forces, since they're not moving, it will be 0. So I got to come up with each one and then plug it in. So F1, all right? I like to do these in standard position by themselves. It makes it a little easier, so I'll show you what I mean. Like, okay, here's my F here, and I know that this is 60 degrees. Okay, so to find that vector, it's going to be some force, so C, and we'll name it C1. C1 times, and it's going to be cosine of 60 degrees, sine of 60 degrees. That's how we always find our vectors. Just the angle, cosine is x, sine is y, and then we multiply it by the magnitude. Now F2 is a little different. This is why I always draw it in standard position. F2 looks like this. All right? So I'm going to use this angle instead of 60. So this angle, if that's 60, the little one, this is 120, right? Because it's got to be 180. So this one will be C2 times cosine of 120, comma, sine of 120. And then F3, we just use our eyes for that. That one already has the magnitude and it's going straight down, so it's 0, negative 450. So I know all three of those are going to add. I also can tell, since these angles are the same, that means the distances are also the same, because that's how an isosceles triangle, right? This goes with 60 and that goes with 60, so they'd be the same, which means the forces are the same. So C1 equals C2. So let's call them C. Okay? So I got C times cosine of 60 degrees plus C times cosine of 120. And I know plus 0, that's this part. So all I'm doing right now is I'm adding this, and that. But the c's have to be multiplied into them. So I know that that is equal to 0. Okay, and I get c, and I'm going to go ahead and just factor that c out. I have a c here and a c here, so I'm going to factor it out. And cosine is 60 degrees, that is 1/2, plus cosine of 120 is going to be negative 1/2. So it really doesn't do anything for me. Do you see that it goes to 0? I get 0 equals 0. Okay, that didn't help. Right, so now I'm going to do, instead of doing the x's, I'm going to add the y's together, and I still got to put the c's. So I get c sine of 60 degrees plus c sine of 120 degrees minus 450, these are my y's, equals 0. Now I'm going to factor that c out. Sine of 60 degrees would be radical 3 over 2. You use your calculator if you need it. Sine of 120 is the same, radical 3 over 2. Minus 450 equals 0. I can add those together, it makes 1, so I get c times a radical 3 minus 450 equals 0. So I'm solving now. C times radical 3 equals 450 now. And then I'm going to divide by radical 3. I'm going to use my calculator here. 450, oops, let me clear it. 450 divided by radical 3. So I got 259.807. 6. Let's go one more. Okay, I'm going to have to plug these c's in now to my vectors that I have up here at the top. So F1 is going to be that number. So I'm going to cheat here and copy and paste. Duplicate. It's going to be this number times the vector that was up here, this vector here. So copy and paste that. I don't really need those highlighting marks, so I'm going to delete those. So F1 then, I just multiply. Let me grab my calculator. Actually, I'll just use the one on the screen. Open, and I'm going to times, I already have that number, times cosine of 60. And let me make sure I'm in degrees before I push enter. I am. So enter, and I got the first one will be 129.9038, comma, and then I'm going to do that same number, so I'm going to go up, copy, enter, times, and I'm going to times it by sine 60 now. So I enter, oh, let me delete one of those parentheses, and I get 225. Nice and pretty. Now, that's F1. F2 is the exact same, except for we know that the x is negative. So it's going to be negative 129.9038, comma, and then 225. We know this by just using our eyes up here, that those two vectors, one points that way, and one's the exact same vector pointing that way, because the angles are the same. So I have those, and then I think in the question, let's make sure I answered what they wanted. I'm pulling it up now. That's the wrong problem. Give me one sec. The force each chain must be able to support is, okay, so what we do now is the force is actually right here, ends up being, if you were to take the magnitude of that force, you would get that. So the answer should be 259.807. It said type an exact answer, so you may want to do C equals 450 divided by the square root of 3. It's probably, instead of, because that's how we got that decimal, and then in my lab it says to type in the exact answer. So that is that. If you were to take the magnitude of your force vectors, you also would get that. The reason I know it's that is because what we created up here are unit vectors. Think about taking the magnitude of a cosine and a sine like that, you're going to get the identity, making it a 1. All right, so our answer is 450 over 3. That's my magnitude. All right, I hope this helps.